The last time you had an infection, you probably weren't given penicillin, even though when it was first introduced, it was a wonder drug which saved the lives of millions of humans and animals. Drugs based on penicillin are still widely used today. In 1928, Alexander Fleming returned to his lab from a holiday to find that mould in a petri dish had killed the bacteria which he had been working on. And at the time, it was unknown to Alexander Fleming that in that mould contained penicillin. The therapeutic benefits of penicillin weren't realised until the 1940s, when Howard Florey and Ernest Chain developed a process to extract the penicillin from the mould. Florey and Chain refined methods of large-scale penicillin production, allowing treatment of penicillin in patients. The first patient to be treated with penicillin was a policeman who was suffering from a life-threatening infection. After 24 hours of treatment, the patient's condition started to improve because the penicillin was fighting the bacterial infection. Unfortunately, the patient later died because they ran out of penicillin. Initially, penicillin had to be taken many times a day by injection. Issues such as this led to the development of other penicillin-type drugs. There's now a whole class of penicillin drugs, and there's dozens of different drugs in that class, so we can treat a wider range of infections, whilst the drugs are more patient-friendly, so they can be taken in pill form. Penicillin is an antibiotic which is used in the treatment of bacterial infections. Certain types of bacteria have a cell wall, and this cell wall is made up of peptidoglycan, which help give strength and structure to the cell. So peptidoglycan is a mesh of sugars and proteins all joined together by something called the penicillin binding protein. Penicillin works by blocking the penicillin binding protein. It fits in like a lock and key and blocking any activity happening. So this means the strands of proteins and sugar can't be joined together to make the mesh-like cell wall. Once this happens, the cell wall is more vulnerable and it starts to break down, and this allows continuous movement of water into the cell. And when this happens, the pressure inside the cell is increased, and it's a bit like overfilling a water balloon. Eventually, it's going to burst and die. Overuse of antibiotics like penicillin has led to a decrease in the ability of antibiotics to fight infection. This is commonly referred to as resistance. Overexposure to antibiotics filter out the weak bacteria, leaving only the strongest bacteria, which have developed ways to evade and resist the effects of antibiotics. Some bacteria can even produce enzymes which can digest penicillin. So this is why you were probably not given penicillin the last time you had an infection.